The Shahab-3 is a medium-range ballistic missile that represents a significant development in Iran's strategic missile capabilities and has been a focal point in discussions surrounding regional security and deterrence. Developed in the late 1990s and publicly tested in 1998, the Shahab-3 is widely believed to be derived from the North Korean NODONG-1 missile design, with modifications and improvements introduced over time to enhance its range, reliability, and accuracy. With an estimated range of approximately 1,000 to 2,000 kilometers depending on the variant, the Shahab-3 provides the capability to reach targets across a broad portion of the Middle East. This range places it among the more influential missile systems in the region, as it alters strategic calculations by extending strike capability beyond immediate borders. The missile is powered by a single-stage liquid-fueled propulsion system, which generates the thrust necessary to propel it along a ballistic trajectory into the upper atmosphere before descending toward its target. While liquid fuel allows for substantial thrust and proven engineering reliability, it also requires pre-launch fueling, increasing preparation time and potentially affecting rapid deployment compared to solid fuel systems. Nevertheless, over the years, improvements have reportedly been made to reduce launch preparation time and improve operational readiness. From a design perspective, the Shahab-3 features a cylindrical body with a distinctive nose cone that houses the payload and guidance systems. Early versions were thought to have relatively limited accuracy, with circular error probable (CEP) estimates reflecting the technological limitations of first-generation guidance systems. However, subsequent modifications, including redesigned re-entry vehicles and potential guidance upgrades, are believed to have improved accuracy and performance. Some variants, often referred to by different sub-designations, are reported to have extended ranges and enhanced maneuverability, indicating ongoing refinement of the platform. These improvements illustrate the iterative nature of missile development, where incremental upgrades can significantly alter performance characteristics over time. The Shahab-3 is typically associated with conventional warhead capabilities, although discussions about its theoretical capacity to carry non-conventional payloads have contributed to international scrutiny and diplomatic debate. Such discussions have been central to broader non-proliferation efforts and regional arms control dialogues. Strategically, the Shahab-3 functions primarily as a deterrent asset. In military doctrine, deterrence relies not only on defensive systems but also on credible offensive capabilities that can dissuade potential adversaries from initiating conflict. By possessing a missile system with extended range, a state can signal its capacity to respond to threats beyond its immediate borders, thereby influencing the strategic environment. This dynamic has made the Shahab-3 a recurring topic in defense analyses and geopolitical assessments. Regional actors often evaluate missile capabilities in relation to air defense systems, early warning networks, and broader force structures, highlighting the interconnected nature of modern military planning. Ballistic missiles like the Shahab-3 are typically integrated into a layered defense and offense strategy, complementing conventional forces, air power, and naval assets. The technological lineage of the Shahab-3 underscores the global diffusion of missile technology over recent decades. Originating from earlier designs outside the country, the system demonstrates how engineering knowledge can be adapted and localized to meet national strategic objectives. Over time, domestic production capabilities and research initiatives have reportedly played an increasing role in sustaining and upgrading the missile program. This progression from initial external assistance to more self-reliant development reflects a broader pattern observed in missile programs worldwide. For viewers of driven vision, the Shahab-3 offers an instructive example of how technological adaptation, strategic planning, and geopolitical considerations converge in the field of defense systems. Exploring the missile's evolution provides insight into how military technologies are not static but continually shaped by innovation, operational testing, and shifting security priorities. Operationally, ballistic missiles such as the Shahab-3 follow a three-phase flight profile: boost phase, mid-course phase, and terminal phase. During the boost phase, the rocket engine ignites and propels the missile upward, after which the mid-course phase carries it along a ballistic trajectory outside the dense layers of the atmosphere. Finally, during the terminal phase, the warhead re-enters the atmosphere and descends toward the target. Each phase presents unique technical challenges, from propulsion stability and structural integrity to heat shielding during re-entry. Enhancements in any of these areas can significantly affect overall effectiveness. Reports of redesigned nose cones and potential re-entry vehicle modifications suggest efforts to improve survivability and accuracy during the terminal phase. Additionally, discussions about maneuverable re-entry vehicles in related systems highlight the evolving nature of ballistic missile technology in response to missile defense advancements. The Shahab-3 has also played a symbolic role in military parades and public demonstrations, where its display serves both domestic and international messaging purposes. Military hardware showcased in such contexts often communicates technological progress and strategic intent. This visibility contributes to its prominence in international media coverage and policy discussions. In the broader context of regional security, the presence of medium-range ballistic missiles influences diplomatic negotiations, defense postures, and alliance considerations. Missile defense initiatives in neighboring countries are frequently evaluated in light of systems like the Shahab-3, illustrating how one capability can shape the strategic decisions of multiple actors. From a technical standpoint, continued refinements in propulsion, materials science, and guidance electronics have likely contributed to incremental performance gains over successive variants. Even modest improvements in range or accuracy can expand operational flexibility and strategic options. For content creators analyzing military systems, it is important to emphasize both the engineering fundamentals and the broader strategic implications. The Shahab-3's development history demonstrates how military technologies are deeply intertwined with geopolitical realities, national security objectives, and international regulatory frameworks. Its existence has influenced conversations about arms limitation agreements, missile defense systems, and regional stability initiatives. In summary, the Shahab-3 stands as a significant example of medium-range ballistic missile development in the contemporary era. Its range, propulsion system, and evolutionary upgrades reflect a sustained effort to enhance deterrence capabilities and adapt to changing security environments. For audiences seeking a deeper understanding of military technology, examining the Shahab-3 provides valuable perspective on how engineering innovation intersects with strategic doctrine. By exploring its origins, technical characteristics, and geopolitical impact, viewers can gain a comprehensive appreciation of the role ballistic missiles play in shaping modern defense landscapes.